This is a quick video to demonstrate how to flash ExpressLRS onto a FreeSky R9 module. So before we start, we need a couple of things. We need 2 of these patch wires with the female ends on them. And you need 2 more of those where we snip the ends off those patch wires and just tin the end with a little bit of solder. So it's just 2 of the normal female patch wires, and I've just chopped the ends off. I've attached a little bit of silicone wire there, but you don't need to do that. And the last thing you need is an STLink V2. And that's pretty much it. Let's get started. Remove the 2 screws from the top of the module. After the screws are out, just pull up from the top side of the module here. Be careful of the antenna cable there because it connects down onto the PCB, that little black one that you can see there. So just be mindful of that as you pull it apart. This all just pulls up and unclips from that side. You just have to pull on this end with a little bit of force and it comes apart. Okay, that top's off now. You can see that antenna cable goes down onto the PCB, but the PCB is loose in the enclosure, so it just pulls up out like that. You can set that aside, and now we've got access to the flash pins that we're after. So the ones that we're interested in, so the flash pads are these C, positive, negative, and D pads here. The clock pad is C, positive and negative for 3v3, and D for the data pad, and those are the ones that we need to connect to the STLink programmer. So we don't actually need the positive and negative pins right there. We can connect via 5 volt via this header here. So if we turn that around so we can see it, you can see the first 2 pins here are ground and +5. So we can connect the STLink to those pins rather than use the 3v3 on the small pads in the middle there. However, we do need to connect our clock and data pins to those 2 outside pads. So I've already put a little blob of solder on each one of those, but go ahead and put a little dab of solder on those pins, and then we'll tack 2 wires onto those 2 outside pins. So take the first one of the patch wires with the end trimmed off, put a little dab of solder onto the end of it, and now we want to attach that to that C pin there. Just carefully using the iron, get in there and just get it attached. Doesn't have to be the prettiest thing, but it does have to be connected. So do the same with the second one of those patch wires that we trimmed the ends off, and attach that to the D pin. Just get the right angle there. Just want to gently attach that. So for the next step, grab the patch wires that still have the connectors attached to them. I'm using orange for positive and white for negative because I'm lazy. But you just want to attach those to these first 2 pins. So ground is the first one and 5 volt is the second one. And that's our wiring done. Next step, we'll connect it up to the STLink. Alright, so we've got our 4 wires connected to the module. We've got our STLink here. So the STLink's got little labels there on each one of the pins. So you want to find the 5 volt and the ground pin. In that case, this is my top one here and the middle one in the middle there. And you want to connect those up to the header with 5 and ground that we connected there. So I connect my 5 to my 5 and my ground to my ground. And then on my STLink on the opposite side, it should probably be the same for yours because I'd assume they have the same wiring. These top 2 pins here are software clock, so SWCLK, and it's difficult to read, but SW data or something like that is the next one in. So the yellow wire that I've connected here is the data wire, so that goes the second one in, and my little blue one here is my clock wire, That goes the first one in there. And that's the STLink wired up. Okay, we've got our antenna connected and the STLink plugged in. At this point, I've already flashed ExpressLRS to this module, but this little green light here will be blinking, not solid, but that's expected. And the next step is to open up the STLink utility program and disable the readout protection flags. So we'll do that now. Okay, so with the STLink connected, select target and connect. You shouldn't get any errors. You should see some addresses come up. Next step is target and down to option bytes. You should see this dialog. I've already gone ahead and disabled this, but it'll come like this with readout protection enabled. So just select disabled and go down and hit apply. And that's pretty much it. And all we need to do is disconnect and we're done. You can close that down. So before you go ahead and flash the R9M, you need to come into this user defines file and uncomment one of these lines depending on what hardware you're using and which piece of the world you're in. So I'm in Australia, I want to run 915 megahertz on this module. So I deselect the first line here and save that. And there's also some other options in this file, but that's all you should need just to get started. So save, and then over here we have the Platform IO extension icon, and underneath that we've got a bunch of targets for all different pieces of hardware that we can flash to. Expand the FreeSky TX R9M via STLink target. So all we need to do is hit the upload button here. This is going to build and then flash the microcontroller. Success. And we have startup tones. So now it's completely up to you whether you want to leave these patch wires attached. I'm going to remove mine off here, and obviously there's power wires there. There's no need to keep that attached for future flashing because we can use OpenTX to flash firmware builds via that method. So you can go ahead and remove the clock and data pin there if you'd like to, and that'll clean it up so you can put all of this back together in the case again. So before you go ahead and put this all back together again, there's one more mod that you might like to do. This little chip here with J6 written on it, that's the inverter chip for the S-port line. And it's the same style inverters that are used on like the Taranis QX7s, which can't handle baud rates above about 115k baud. So if you want to, or if your handset is locked to 400k baud, you want to do the resistor mod on this chip. So the resistor mod, fairly sure is detailed on the wiki on ExpressLRS GitHub, but basically this top pin here on the inverter needs to be pulled via about a 500 ohm resistor to 3v3. So I've quickly done my inverter mod. You can see off the top pin of that inverter I've attached a 470 ohm resistor, just a little chip resistor to keep it nice and clean. And I've got some motor winding wire just running down over to that 3v3 pad over here where I've just scraped off some of the green protection, and I've just routed that around there like that. It doesn't have to be anything pretty, but you want to do that if you want to use higher than 115k baud on your TX. Okay, should be good to put it all back together now.